everyone, welcome to Jinghua Education. I'm Steven. In this video, we're going to talk about Calculus 1, Limited Tutorial Part 9, how to use squeeze theorem to find the limit. Okay, I assume you read the book. I also assume you don't understand the book. Okay, the book talking about squeeze theorems is using a bunch of conditions, rules, theorems, and then a very elegant, well-written mathematical languages, and then it just not make sense. Okay, I'm going to show you a very simple and then very easy to remember way to show you what is the squeeze theorem is about. Okay, so for example, I want proof you going to enjoy my video. How do I prove that? Okay, I found someone smarter than you. Okay, someone's like a lot of always smarter than you, and then I prove this guy is going to like my video. And then I found someone else is always not as smart as you, and then I prove that guy is also like my video. So you are in between of this smart guy and the not smart guy. Okay, I tell you both of them is like my video, so you are in between. You should be like my video. That is the ideas of squeeze theorems. Apologize if you don't like my examples. Okay, so but at least you got idea what is squeeze theorems. Okay, so when we transfer into mathematical world, for example, I have a graph here. Okay, I want to show you when x is approaching to a, the y suppose approaching to this number fa. Okay, so when x approaching to a, y is supposed to be approaching to fa. Okay, how do I do that? I will find some other functions. These functions is always bigger than the function we have. Okay, we also find another functions. This function is always less than the function we have. Okay, and then I prove this function, purple function, and then these blue functions are both approaching to fa when x approach to a. That means your functions is in between of these two functions, right? That means this function, the black function, must be approaching to a because he's less than these blue functions and bigger than this purple function all the times. If the higher one, the lower one, they both approaching to the same values, that means the middle one must be approaching to these values. That's why we call them squeeze theorems, using higher one and lower one to squeeze the answer here. Normally, when we use these questions, when we have very complex functions, and then almost every time we using squeeze theorems, we dealing with trigonometry functions. Okay, let's see this function here. Use squeeze theorem to determine the value of this one. Okay, so we got x force, we got sines, pi over x, we got a lot of things here. Okay, however, every time we see these things, we know sine function has boundaries. What is a boundary? Sine function doesn't matter how big inside. Doesn't matter how big inside. As long there is input for sine function, the sine function maximum value is 1. The minimum value is -1. Make sense? Good. So that means our function f4 sine pi over x functions is going to less than x power of 4 always, because this guy's maximum is 1. When they got maximum, they got these things. The minimum is -1. That means when they got the minimums, it got negative x force. Okay? That means as long as we prove limited x approaching to zeros, negative f4, limited x approaching to 0, positive x4, when we approve these things are both equal to 0, that means the middle one must be equal to 0. Okay, it's very easy to prove, right? We just plug in zeros into the functions, and that's it. We don't have any denominator problems. We just 0 here, we got 0. It's the approaching 0 here, 0 power of 4 is equal to 0. That means both the upper one, and then the lower one is approaching to the same values when x approaching to 0. That means the middle one do not have a choice. They must approaching to 0. that is final answer. Okay, so I hope you understand this. I hope you like my examples. Okay, if you don't, just you can read the book. Okay, so if you like, please subscribe. It means a lot to me. If you have any questions, just leave the comment below. I will answer your question in my next video. Thank you for watching.